Hello, um, good morning everyone. I'm Annu Maheshwari. I'm pursuing my PhD from CSE department at Patent University. I'm here to talk about the introduction of Keras, which is based on TensorFlow. So in today's talk, I would like to tell you about the brief introduction of Keras and somewhat about TensorFlow. So Keras is capable of running on top of TensorFlow and Theano or ZNTK. There are various deep learning libraries which are used for prototyping our ideas. Um, Keras is written in Python. We can do our programming in using Python um, and using Keras for deep learning. It can also run on CPU and GPUs, graphic processing units. Keras is compatible with the versions of Python that is 2.7 to 3.6. In this slide, I try to cover some of the companies which are currently using Keras. This is a list of some companies which are using Keras um, for deep learning neural networks and for solving complex neural network problems. Uh, These companies include Google, OpenAI, DeepMind, Snapchat, Uber, Airbus, eBay, Dropbox, and a bunch of startups. So these are the companies which are currently using Keras. In this slide, I would like to tell about the applications of Keras. Actually, we mean what we mean by applications. Applications are the areas in which we can use a particular technique or a technology. In this slide, I would like to tell about the applications of Keras. Keras applications are deep learning models. Actually, Keras is applied by using these deep learning models, which are based on pre-trained weights, which are already trained, having some weights, having some predefined or pre-trained weights. And these models can be used for prediction, feature extraction and fine-tuning, applications of image processing, and various other domain can also use Keras by using these learning models. Uh, Here is some of the models which are used for image classification, and these are with weights trained on ImageNet. The models are Exception, VGG16, VGG19, ResNet 50, Inception V3. All of these models are compatible with TensorFlow or Theano deep learning library, except the first one, that is exception. This exception model doesn't support neither neither Theano nor TensorFlow. So these are some deep learning models which are used as Keras applications for various um, machine learning problems, for to solve various machine learning problems. Um, Before getting started with Keras, I would like to tell about something on TensorFlow. Because if we want to work with Keras, then we have to install Keras. But first we will have to install either TensorFlow or Theano. Because Keras is capable of running on both of the deep learning libraries, that is TensorFlow or Theano. But if we want to work with Keras and we want to install Keras, then firstly we will have to install TensorFlow. So I would like to go with TensorFlow. So my topic is Introduction to Keras based on TensorFlow. That's why I have in this slide about TensorFlow. So what is TensorFlow? Actually, TensorFlow is a deep learning library for solving numerical problems or for doing computations, numerical computations. Um, it is basically an open source software. Uh, it deals with data flow graphs. Actually, it does numerical computations in the form of data flow graphs. So we can say that TensorFlow is a deep learning library which is used for numerical computation, and it uses data flow graphs for notifications. TensorFlow is originally developed by Google Brain team to conduct machine learning and deep neural network research. It was basically developed by Google Brain team. We can say that TensorFlow is an interface for expressing machine learning algorithms and for their implementation to execute such algorithms. TensorFlow provides an extensive suite of a number of classes or functions which we can use to build various models from scratch. So if we look at the word TensorFlow, then firstly the question arises, what's a tensor actually? So as I have already told you that TensorFlow works using data flow graphs. So graph nodes are operations. Graph nodes are operations which have any number of input or output, and graph edges are the tensors which carries the data from one node to another node which carries data from one node to another node. So TensorFlow is a combination of graph nodes and graph edges, where graph nodes are the operations which can have multiple number of inputs and outputs, and graph edges are the tensors which deals with the actual data. And these data can be stored in n-dimensional array. If we are having zero-dimensional array, then we will call it as zero-dimensional tensor. That is known as that can be a scalar or a number only. If we are having one-dimensional array, then it is called as one-dimensional tensor. That can be a vector. And if we are having two-dimensional array, then we can call it as two-dimensional tensor, and that can be a matrix also, and so on. So what we can conclude from this slide, that a tensor is a data. Tensor is the data, and we can store these data into n-dimensional arrays. So in Python, we can use the NumPy arrays to store these data and um, these tensors for TensorFlow or for our data flow graphs. Mm, so so actually uh, basically tensor tensor works or tensor uses data flow graphs to show the numerical computations in deep neural networks for their learning. uh, how we can install or how we can use TensorFlow in Python? If we write like this, import TensorFlow as df, then we will be able to use TensorFlow deep learning library for our computation, for numerical computation. And if we want to install TensorFlow, then we will go with the pip installation process, and we can simply write pip install TensorFlow on the command prompt of the um, py installation. So after writing pip install TensorFlow, we will be able to install TensorFlow in our Python IDE which supports Python, in any IDE which supports Python. So as I have said that TensorFlow uses data flow graph. So here if we want to add 3 and 5, these are two numbers. So If we want to add this 3 and 5, then we will write a is equals to tf dot add 3 comma 5. Um, we are not using over here any x or y or l or m or n, any variable name for these 3 and 5 two numbers. Why? Because TF automatically names the nodes, but we don't explicitly name them. If we are not giving any explicit name 2, 3 and 5, then TF will automatically give some explicit name to them. So by writing this one line, we can add two numbers in data in TensorFlow. So TensorFlow works in the data flow graphs using data flow graphs. Here we can see that there are three nodes. This is one node and this is one node, and we are having this node. So these nodes represents the operations. That is, here we are applying add operation on these two nodes. So operations are so graph nodes represent the operations, and these edges represents the tensors like this. These edges represents the tensor, that is the data which flow between the graph nodes. So how data flow graphs interpreted the nodes and nodes value and data. So it is having 3 and 5 as tensors of this particular data flow graph for the operation add. So we are having three nodes over here, and we are having edges that represents the tensors, that is actually the flow between the nodes, which is the data. So nodes, here I have written nodes represents the operators, variables and constants, and edges represents the tensor, that is the data. How we can interpret this? We are interpreting this as that tensors are the data, that is 3 and 5, and data flow deals with the tensor flow, that is it is flowing the data from one node, that is x node or y node, to the add node to add those values or those data. So as we simply say I know, that means something flowing in our mind, that we know about something. So if we say that I know, that means there is a flow within our minds, that is the tensor flow. That tensor flow will contain the data about which we have already known, about which I have already known. Okay, so this is data flow graph for adding two integers, that is 3 and 5. Uh, while we add, um, while when we want to add two numbers, then the in TensorFlow, then the data flow will think about it, that how will I get the value of a. It will think about that how it will be able to get the value of a, that is 3 plus 5, that is 8. So now we will look at this point, that how it will be uh, able to get the value of a. So it will create a session and assign it to a variable, that is, you can name it, you can give any name to this variable so that it can represent the session which we have created, and we can call it later by using this variable name, by referencing this variable. And within this session, it will evaluate the graph to fetch the value of a. uh, Within this session, the data flow graph or the tensor flow will use the graph nodes and graph edges to evaluate the value of a, so that it will be able to get the value of a. Now see how will it be possible for getting the value of a. So if we are writing import TensorFlow as tf and a is equals to tf dot add 3 comma 5, This TF will work as data flow graphs, and it will create two nodes 3 and 5, or give explicitly name to them, that is X or Y or whatever it can be. um, and it will use graph edges to connect these graph nodes with a resulting graph node, that is A. So what it will do, it will do um, it will firstly it will create a session that is used to assign that is used to generate a executing environment for executing this particular add operation, for executing this particular add operation. Okay, so what we can write, A is equals to tf dot add 3 comma 5, and after that we will try to create a session and we will write tf dot session. This session method is used to create a session. So after creating a session, we are assigning it to a variable that is known as SESS, or session, we can call it session. So we can use this variable to call it later, or we can use simply this variable to reference the session. So after this third line, I have written print session dot run, and as an argument I have passed A. So for this A, this session will run, which I have created using tf.session. So this executing environment will execute for calculating the value of A. So by using this phenomena, this will be able to get the value of A, and it will perform the addition operation on these two 3 and 5 values. So within this session, they are trying to evaluate the graph. They are trying to evaluate the graph nodes, and they are trying to evaluate the graph edges to find out the tensors or find out the data which are flowing between the graph nodes or graph edges using graph edges. So it will try to evaluate the graph within this session to fetch the value of A. And lastly, this code is trying to close the session after after completing our task of getting the value of A, we should close the session. So it will be helpful for memory usage, or uh, for avoiding extra memory usage. Okay, so by using session dot close, we will be able to close this particular session which we have created in this particular line. Okay, so as the session creates, the session will look at the graph and trying to think like, hmm, how can I get the value of this A by using these graph nodes, or which or all the nodes which are leading towards to A. By computing, then it finds that by computing all the nodes which are leading towards the A, it will be able to compute the value of A. Okay, so this is how to get the value of A in TensorFlow for a simple operation, that is add operation, addition. And simply in this slide we will be able to know that print session dot run A will give us 8, because uh, with the flow of tensors as 3 and 5, this sorry, this add operation will be able to add these 3 and 5 tensors, and will be able to run the session for calculating the value of A as 8, and it will pass this value or flow this tensor towards the next node if we are having any other node. So in this slide, what we can do else, except writing this session starting and session closing statements, we can simply write with tf.session as session variable. This is the variable which we are using to assigning a session, and simply write print session.run a. So except writing of instead of writing 4 to 5 lines of code, we can simply write 2 lines of code to calculate the addition of 3 numbers or 2 numbers or some integer values. So motive of this slide is to write minimum number of lines or minimum number of statements for executing our objective. Okay, so simply while writing with tf.session as session variable, we can refer these 2 lines. We are creating a session and using this session for evaluating the graph to fetch the value of a, and then closing the session. Okay. Um, tf.session. This tf.session method is used to encapsulate the environment. It actually creates an executing environment in which we can perform we can which in which we can execute the operation objects, and we can evaluate the values of tensor objects. Like in previous example, what are the operation objects? We are having addition object operation over there, and we are having tensor objects that are 3 and 5. So session object tf.session is used to create a session object that will encapsulate the executing environment for operation objects, for execution of operation objects, and for evaluation of tensor objects. Here I'm giving some more graphs so that we will be able to understand the concept of data flow graphs which we are using in TensorFlow. So here in this example, what you can see, we are having 2 nodes x and y. We are giving some name to them, explicitly some name to them. That is x equals to 2 and y equal to 3. We are having one more variable, that is operation 1, which is indicating tf.add x comma y, which is showing that this operation will perform by the addition of x and y. In the next line, we are having operation 2. We are having operation 2, which is showing that operation 2 is the result of multiplication of x and y. And operation 3, we are having operation 3, which is the resultant operation of operation 2 and operation 1 with power operation. So in this slide, what we are trying to do, we are trying to perform 3 operations, that is multiplication, addition, and power. Okay, so if you visualize this code at tensor board or in the form of data flow graphs, so we can visualize like this. We are having one node which is known as multiplication, and it is having 2 more nodes which are leading towards it as x and y for the multiplication operation. Similarly, for addition, we are having one node that is representing addition, one graph node which is representing addition, and it is having 2 more nodes which are the same nodes as x and y and leading towards the addition graph node. Okay, and these 2 nodes will generate 2 scalar values which are leading towards the power operation, which are leading towards the graph node that is known as power. Okay, so if I would like to proceed further, then what I will write, I will try to create a session which we have created first in the previous slide. So what we will use with tf.session, uh, tf.session uh, with tf.session, we will create a session variable that is known as session, and we will use this session variable to execute our operations. That is, our motive is uh, uh, to process or execute the operation third. So what we will use, session dot run objective operation third. So for executing this operation, what it will do, it will first execute for multiplication, it will first create for addition, then it will first create for multiplication, and then it will find the two scalar values which it will be used for executing the third operation. Okay. Similarly, we can use the concept of subgraphs in the TensorFlow. Uh, uh, in this diagram, what you can see, we are having code for this diagram. We are having two graph nodes, that is 2 and 3, that are data nodes. We are having add operation, which is using x and y in the form of addition. We are having multiple operation, which is using x and y for as for their multiplication. We are having one more operation that is known as useless. Useless will doing something useless. It is doing multiplication with x, that is 2, with the output of this operation, add operation. Okay, and we are having power operation, one more operation, that is power operation. So power operation, what power operation actually doing, it is computing power of addition operation output and multiplication operation output. So if we are going to create a session, that is tf.session, then firstly we will create a session, that is tf.session, and we will assign it to a variable that is known as session. And what we will like to execute, we are like to executing session.run, that is power operation. So in this graph, what we want to calculate, we actually want to calculate only power operation, which is having no direct correspondence with the useless operation. So uh, we actually want to calculate only the power operation value. So power operation value having two arguments, which is having add operation and multiplication operation. So with this power operation, there is nothing to do with useless operation. So it will save our computations and it will also save the memory spaces. So, so this concept of subgraphs can be used to save computations or save memory usage for TensorFlow. So what if we want to build more than one graph? If we want to build more than one graph, that means we want to build multiple graphs. So multiple graphs will require multiple sessions, as we have seen that in data flow graphs or in TensorFlow, we would like to create a session. And this session will try to use the available resources by default. So for multiple graphs, we will have to create multiple sessions, and each will try to use all the available resources by default to done the execution perfectly. So we will not be able to pass the data between them without passing them through Python or NumPy. Actually, we are using Python, in which we are using NumPy arrays to store the tensors or to store the data. So we will not be able to pass the data between all of the multiple sessions of multiple graphs using Python and NumPy, because Python doesn't because NumPy and Python or NumPy doesn't work in distributed environment. So it's better to have disconnected subgraphs within one graph. So if you want to build more than one graph, then we will go with the disconnected subgraph concept within one graph. So how we will do that particular concept of disconnected multiple graphs or subgraphs within one graph, by using tf.graph. So while using tf.graph, we can add operators to a graph and set it as default. Okay, so we have created a graph tf.graph and we are assigning it to a variable that is g. So if we are writing as with G dot as default. So we are going to set it as default, this graph G, and we will use this graph to perform addition on 3 and 5. And if we for creating our session, we will use this G reference because we have mentioned it as default. So this is a default graph. So we can use this default graph wherever we want to reference that particular graph to perform any operation. So by using this tf.graph, we can use disconnected subgraphs and compute and execute the computations of particular operation. Why TensorFlow go with graphs? Actually, this question is a very good question, and this slide gives the all answers. Gives all the answers. Why TensorFlow chosen graphs? Because graphs save computation. First of all, if we want to run only subgraphs that lead to the values we want to fetch, then we will only run those particular subgraphs, not all the graphs which are including in one graph. So it saves computation. Secondly, it breaks computation into small differentiable pieces to facilitate auto differentiation. uh, we are having subgraphs, so we will be able to compute into small pieces. Okay, okay. Then we will merge these small computations or these results of small computations into one to get the actual output. And thirdly, it facilitates distributed computation, spread the work across multiple GPUs, CPUs, or devices. Graphs are most compatible data structure uh, that can work across multiple GPUs and CPUs. And lastly, many common machine learning models are commonly taught and visualized as directed graphs already. Uh, there are so many machine learning models which are already existing in the current world. So they all are taught or visualized by using directed graphs already. So um, in this slide, I'm going to give you one example of TensorFlow so that you will be able to understand what is exactly TensorFlow flows or what is exactly in TensorFlow flows. So my problem statement is linear regression learning algorithm. In this example, we are trying to perform linear regression learning algorithm, and our objective is to find out the best linear fit to available data. We want to find out the best linear fit for available data. What is the process we are using in this example is we will train the model and then test the model. Firstly, we would like to train the model using TensorFlow, and we will try to test the model. The output of this particular problem statement will be best linear fit. That will be a graph. Okay, and we will do this implementation using TensorFlow, and our language will be Python. And on the IDE JetBrains PyCharm Community Edition, we will use this IDE for our problem statement for linear regression learning algorithm. In the end of this video, I will I have attached uh, I have attached a video which is I have attached the part of video which is describing the integrated development environment IDE PyCharm, which is using TensorFlow and this particular example. Having this particular example. Okay, so what what are the steps which I'm including for solving this particular problem statement of a linear regression learning algorithm? First, we will build a graph using variables and placeholders. We will use variables and placeholders. Um, we, as I have already taught you that we will go with data flow graphs. We will go with data flow graphs So uh, what we will do first, we will try to build a graph using variables and placeholders. And mm, variables are the stateful nodes which output the current value, which output their current value. That is, if we are having linear regression, that means we are having this equation: z is equals to w multiplied by x plus b, where w is the weight and x is the input and b is the bias. So variables are the stateful nodes which output their current values for each iteration. That is W and B, that is weight and bias, will be our variable. And state of the variables is retained across multiple executions of a graph. Okay, and placeholders are the nodes whose value is fed in at execution time, whose values are fed into execution time. Actually, this x will be our placeholder. These are the inputs labels which we are using uh, for our algorithm or for our experiment. These are um, these are fed into the system at execution time. Okay, so first we build a graph using variables and placeholders. Uh, we will use these placeholders for labels. Labels are those which are representing, labels are again placeholders which are representing a ground truth value against a value for which we are trying to train our model. Okay, so we will use placeholder for labels. In the example you will be able to understand that what I'm trying to say over here. um, so while you will look at the IDE, which is having the actual code of linear regression learning algorithm in Python, then you will be able to understand what I'm actually meaning by labels. Or for this time, you can assume, or you can say labels as the predicted output, which we are trying to compute while by training our model. Okay, and that will be used. Okay, later. Set model weights, that is W and bias. We will set the initial values for weight and bias for our model. Then next step is to construct a linear model. This linear model will have an activation or prediction values. This activation value will be computed uh, by applying multiplication operation with W and X, and getting a result of this multiplication operation, and add this result with the bias value to get the activation value. So we will have written line of code for doing this, constructing a linear model in Python. Okay, and after that, for linear regression we will have to calculate the loss values for each node using these labels and these predictions. uh, these Using these labels and predictions, we will be able to calculate the loss value for each and every label, or we can say for each and every data, or we can say for each and every instance of our available data. If we are talking about a number of images, then that means we will have to calculate loss node for each and every image. And further, if we want to go in deep, then we will have to calculate loss value feature for each feature of each image. Okay, okay. So we will calculate loss node using using labels and predictions for each image. For now, I am taking one image only, and after that we will calculate cost function for all the labels. All the labels means for all the images. If I am having a bunch of images, then I will try to calculate the cost function for all the images. Okay. Next, we will try to compute gradient descent. Actually, in linear regression learning algorithm, what we are trying to do, we are trying to predict the output of our model which we are training and compute the error values with um, using predicted output and the actual output. So we will compute gradient descent to reduce this error, to minimize the error actually. So we will compute after calculating loss value for each label and cost function for all the labels. We will next compute the gradient descent for our model. And after calculating or computing gradient descent, we will try to train the model. That will include some of the steps which I have written already in the slide. Training model includes deploy the graph onto a session, that is execution environment, that we have already talked about. Tf.session will be used to create the session. So for training the model, firstly we will try to deploy the graph onto a session, and secondly we will create a session, and thirdly we will build training schedule, how we are going to train the available data using loss and cost function and the gradient descent values. And lastly we will run optimizer that will try to reduce, that is actually used to reduce the values of error, to minimizes the values of error, and then fit all the training data. And finally we would like to display that I have used this algorithm example. In this example I have lastly displayed all the values which I have computed using linear regression learning algorithm, and this display include training cost, cost, value of weight, value of bias per epoch step. Here epoch means iterations, number of iterations we are using to train our models, and the testing cost, absolute mean square loss difference. We will calculate cost for training data and we will calculate cost for testing data. Then we will able to find the absolute mean square loss difference between these two costs. And lastly I would like to show a graph with original data, and one more graph is there for testing data that will tell us about the best fit for our available data. Okay. So summary of TensorFlow can be written as that firstly we will have to go with build the graph, and in building the graph we will use feed forward or prediction methods to initialize the weight and bias values. And secondly we will use optimization, gradients and optimizer to reduce the error, to reduce the absolute mean squared error or loss difference whatever we have calculated. And next we will initialize the session using tf.session, and we will run that session using session variable dot run, and then train with session dot run, and this session dot run will use optimizer, weight value and bias value as an argument, and lastly we will generate output. So previously that was about the TensorFlow. If we want to go with Keras, then we will have to first understood about the behavior of TensorFlow. Then only we will be able to know about the Keras. Now I would like to tell about what is Keras. Uh, what is Keras? I have already said that Keras is a high-level deep learning library which is capable of running on the top of TensorFlow or Theano or CMTK deep learning libraries. Okay, so the core data structure of Keras is a model. Uh, a model is a way to organize layers. In Keras, there are a number of layers we can use. So the most most important data structure of Keras is a model. In this data structure model, the simplest type of model is sequential model, which is a linear stack of layers. In this sequential model, we will linearly store, or we will linearly organize our layers. So let's take a look that how sequential model works. We will import sequential by writing this line from keras.model import sequential. Uh, okay, and we are having model variable, a variable that is named as model for sequential method, that is representing sequential model of Keras. Okay, so if we want to stack some of the layers in this model, then what we will use a add method. How we will use this add method using model? We will write model dot add dense units equals to 64, input dimensions equals to 100. Okay, what it actually tells about, it is going to add units, 64 units, which are having input dimensions as 100. Okay, so in the input layer, there are we are having 64 units, and these 64 units having 100 input dimensions, which are feed forwarding towards the next layer as input. Okay, and we would like to add activation function as ReLU, that is rectified linear unit. Okay, so by using model dot add, we can also talk about the activation functions, what which activation we are going to use to train our model. There are a number of activation functions available, that is, first of all, first of all uh, I like to use always first of all we will like to use always sigmoid function or 10h function. We can use ReLU or leaky ReLU. ReLU mm, is a solution to overcome the bottlenecks of sigmoid function. We are having sigmoid function graph between 0 to 1, and we are having only some of the area where we can where we can see the fast learning behavior, and a small area, or except this small area we are not able to uh, see the fast learning process. Okay, so ReLU is the remedy for bottlenecks of sigmoid. It is a rectified linear unit function, activation function. So by using model dot add, we can use activation. mm, We can stack layers in the sequential model. Okay. Okay. So after creating a model with a second number of layers or using dot add method, we can make a model which is a sequence of some layers. So after doing this, we can configure our model for learning process with using dot compile method. Here I have written a syntax of a line of code for dot compile method. This dot compile method uses three arguments mainly, in which the first one is the loss. It tells about the objective function, that can be the loss function of our model. Here it is specified as a categorical cross entropy, or we can also write over here any loss function, cost function values on the basis of which we are computing our error. And second argument is for optimizer. Optimizer is denoting the optimization object. Here we are using a standard deviation for this. There are so many optimization objects are available, so that we can use any number of optimization objects over here. Uh, Basically, it includes the gradient descent optimization object. And last argument is matrices. This is a matrices. mm, in this there can be a list of matrices which are going to be evaluated by the model during the during training or testing. Here we have mentioned as accuracy. We can also compute efficiency, um, and all that. So generally we use accuracy for matrices, and we compute accuracy during the testing time and the training time. Okay, and after this we can fit the model by using dot fit method, model dot fit method, which will fit the model. That means that will iterate training data in batches. In dot fit method we have mentioned batch size, that is equals to 32, and epochs is equals to 5. So we are trying to iterate training data in 32 batches, batch size of 32. Okay, and after fitting the data for training data, fitting the model for training data, we can calculate predictions. We can calculate predictions by using train on batch method. That is, train on batch is a method uh, which is update the single gradient over one batch of samples. Over one batch of samples, it updates the single gradient every time when we train on batch, when we calculate the prediction for each and every batch. So we will use dot train on batch method, and it is taking arguments as x batch and y batch. This is the number of batches. Uh, this can be a one batch of sample. Okay. And after that, we will calculate loss and matrices. As we have mentioned earlier, that we will calculate loss as categorical cross entropy for nonlinear learning algorithm, and matrices as accuracy for nonlinear learning algorithm. So we can, after calculating the predictions, we can go for loss and matrices. So for loss and matrices, we have to use model dot evaluate. Evaluate method is used to evaluate these loss function objectives and matrices of the model, and it takes the x test and y test and batch size as its arguments. This x test and y test are the testing data for our model, and after calculating the predictions uh, we can go for save prediction, so that we can predict our model with the input test data. So for predictions we will use dot predict method, which is having its argument, which are written on the slide. Okay. Um, so this is the code, for example, of Keras, which I have told you already. This is having its own deep learning libraries and all the Python libraries. After that, it read the data from CSV file. It is actually performing the Keras, performing the operation of nonlinear and learning algorithm on a CSV file for training and validation data, and it find out the training set and validation set and store them into the numpy arrays. After that, they have split them into input and output variables. So we are having training set variables and we are having validation set variables. And after splitting the variables into input and output, it is creating model using sequential model of Keras library, and it is adding layers to this model using dot add method, and it is having its own arguments or attributes for creating layers. After that, it is compiling the model using dot compile method. It is having loss function as mean square error, and it is having optimizer, which it is named as ADAM, and matrices. It is also calculating matrices for training and testing time as accuracy. It filtered the model for epoch 5000. It has written a number of epochs as 5000. That means these are the number of iterations to train the model. So it is trying to train the model for 5000 iterations. And after that, it is calculating the predictions and saving the predictions as well to show the output. So here in the slides you can see the output which are having training set r square with some accuracy value and validation set r square with some accuracy value. So this is the output of the previously defined example of Keras. And lastly, these are the references which I have taken from these references. I have taken the material or concepts of TensorFlow and Keras and examples of Keras and TensorFlow. I hope you would enjoy the video, and this is my a small step towards the TensorFlow, towards the Keras based on TensorFlow. And lastly, I would like to show the example on PyCharm IDE, which I have taken from github.com. Thank you so much for your patience. So here on the screen you can see IDE, that is JetBrains PyCharm Community Edition IDE. I have used this IDE for running the example of TensorFlow. So here you can see the lines of code in Python which I have written in Python. I have taken this example from github.com and I have mentioned the reference for this example. So what the author has done in this example, firstly the author has have included all the deep learning libraries for solving neural network problems, and also the Python libraries and matplotlib libraries for plotting the resultant graphs. And firstly, the author tried to build a graph using variables and placeholders. So it has variables are the parameters in which we are interested actually, which have direct correspondence in the models. Here we have written parameters. Uh, Parameters are not variables. Um, mm, um, um, x and y also are not parameters like this, where here we are having train x and train y. These are not parameters, these are training data. Okay, so initialize some variables like learning rate as 0.01, training epochs, number of iterations is 1000, and display step is 50. Display step will include because of if you want to display 1000 epochs, then we will try to display uh, interval between epochs. So we are having 50 interval, so the example output will start from 50 epochs, then 100 epochs, then 150, then 200, and so on until 1000. Okay, uh, in this next we are having training data. So this training data is the train x and train y, which is our input, which is in the form of numpy arrays. So we are storing values of x and y as in numpy arrays. And we are having one more training data, that is n samples train x dot shape. We are reshaping the x train x variable, and this will denote the number of samples. Okay, so what we will do first, tf graph input. First we will try to plot the graph, and this graph will take graph edges and graph nodes. So x represent the graph node, which is a placeholder, and placeholder is used for initialization of parameters. Placeholder denotes a state of the input, okay. So we are having tf graph input as x is equals to tf dot placeholder, that is of float type, and y is equals to tf dot placeholder, that is again of float type. Okay, after that what we will do, why we are using labels are the placeholders which are used for ground truth against for the values which are for we are trying to train the model, against the value for we are trying to train the model. Okay, so labels are y in this example. After that we will try to set the model weight. Okay, we will try to set the model weight, that is w is equals to tf dot variable and b is equals to tf dot variable. By using tf dot variable method we can set the values of weight and bias. Similarly, we can also do this with tf dot variable scope method. There is one more method that is known as tf dot variable underscore scope method, which provides simple name spacing to avoid clashes. This tf dot variable scope method uses name spacing, uh, which avoid clashes, and this also creates and accesses variable from within a variable scope. There is one more method that is known as tf dot get variable. This get variable method is used to create or access the variables within a variable scope. If you are using tf dot get variable, uh, this this is also used to create a variable which is not if a certain name variable doesn't exist, or it will also find that variable if two variables of same name exist. So if we want to use tf dot variable, then we can use to set the model weights, and if we want to use tf dot variable scope and tf dot get variable methods to do this task, we can also go for this. And next to this we will construct a linear model, that is the linear model which I have talked which I have told about earlier about which I have told earlier. uh, this linear model will consist of w bias and x input. So this will calculate the value of predicted output, that is predict that is equals to tf dot add tf dot multiply x comma w, that represents w multiplied by x plus b. So this will construct a linear model, and after that we will calculate loss function node for labels and predictions. So by using mean square error we will calculate cost is equals to tf dot reduce sum tf dot power predicted minus y up comma 2 uh, upon 2 into n samples. This is the mean squared error formula for calculating the cost for all the labels. TensorFlow automatically converts addition, subtraction, and element-wise multiplication TensorFlow operations. Into TensorFlow operations. Okay. Then we will calculate the cost function for all the available data. For all the available data, like this. Okay. And after that we will compute the gradient descent. We use the gradient descent to minimize the variable objects that are trainable, that is w and b. Okay, so in optimizer we are having tf dot train dot gradient descent optimizer method, which is including learning rate as an argument dot minimize cost. This gradient descent optimizer is the optimizer object. We are having learning rate as an argument, and we have already set learning rate at 0.01. This whole line adds this whole line of code adds optimization operation to computation graph. This 61 line number will add this 61 line number will add operation to the computation graph. Initialize the variables and assign their default variables. After that we will initialize the variables and with their default values. Hmm? Mm. In this line 61 line number, um, in this 61 line number, the minimize method, that is minimize method. This is a minimize method. uh, it does it does two things. it computes the gradient of our argument, that is cost, with respect to all of the variables defined in the graph, bias and weight, and it apply the gradient updates to those variables also. Firstly, it computes the gradient of the argument with respect to all variables defined in the graph, that is bias and weight. And secondly, it applied the gradient update to those variables also. So that means this minimizes methods, firstly calculating the gradient with respect to all the variables and then updating the gradients to those variables also. Okay, in TensorFlow, how we will calculate or compute the gradient? In TensorFlow, there are two methods available so that we can calculate the gradient updates. First is TensorFlow graph nodes have attached gradient operations. In TensorFlow graph nodes, all the nodes have are already attached with the gradient operations that has a pre-built gradient of output with respect to input. And secondly, the gradient with respect to parameters can be computed with back propagation through the graph using the chain rule. Gradient with respect to parameters can be computed with backpropagation through the graph using the chain rule. So in TensorFlow, there are two ways to calculate the gradient descent. Either we can use the gradient operations which are having the pre-built gradient of function, and or we can calculate the gradient with respect to parameters with backpropagation, computed with backpropagation. Okay, and lastly what we will do, we will start the training. We will try to train the model. We will deploy the graph onto execution environment, that is session. So we will create our session using tf.session, and we are having one variable that is known as session variable to refer the creation of session. And firstly we will create the session, then secondly we will run the initializer while using the set.session.run. This initializer initializes the variables. This initializer initializes the variables, that is w and bias. Run a loop. After that we will run a loop for number of iterations, for how many number of iterations we are going to train our model, that is training epochs. That we have set at as 1000. And loop includes a batch for input. That is indicating optimizer from a feed directory that is having x:x. Here capital X denote a batch for all levels and a small x denotes a batch for input. So we are having two placeholders or two items, or we can say two numpy arrays. Okay, so lastly in this loop we can show that how we can be able to print the number of epochs, the value of cost, the value of weight, and the value of bias for training data. And after optimizing the training data we will also calculating the training cost, and we will display this training cost. And after optimization finished, we will be able to test our example using testing examples, the value of x test and xy test. We are trying to calculate the testing cost and then training cost. And lastly uh, we will try to print the absolute mean squared loss function, which is the absolute subtraction of training cost and testing cost. And lastly we are trying to plot the data, plot the graphs of plot the graphs with the labels training data and testing data, with original data and training data. So I would like to run this. uh, so this is the example for TensorFlow for linear regression learning algorithm. Uh, so here you can see that it is showing the number of epochs, cost and weight, values and biases. Uh, for epochs with the 50 interval. And lastly we are getting optimization, finished message, and then training cost. And we are having one graph over here which is having original data with a fitted line. And after closing that graph we are able to get the testing mean square loss comparison. That means we are having a one more graph which is having testing data and fitted line. So we are able to find out the best fit for our available data using this algorithm for linear regression learning algorithm. Okay, so so in the output you can see that there is a testing cost and training cost, and we are able to find out the absolute mean square loss difference between these two costs. So we are able to do the process of linear regression learning algorithm. Thank you.